Good evening, everyone. Assalamu alaikum. A little bit about me. My name is Mohammad Zafar Khan. I'm third year computer engineering student. I work at AUV in the computer vision, sensor fusion interfacing, and deep learning. This is a short overview and outline of what I will be discussing. Since it is very important to distinguish and understand what is exactly autonomous in case of autonomous underwater vehicle, because we already have discussed, a lot of people have already told you about underwater vehicles, but the fact that that vehicle is autonomous is very interesting and intriguing. And the next we will be discussing, breaking the presentation into two parts: an electronic team and their responsibilities, as well as the computer team and their responsibilities. We will discuss what are your responsibilities in a team, as well as what you will learn when you join the team, and what are the future possibilities. And in electronic section, the standard tasks, the boards, we will get into some detail of the sensors, as well as similarly in computer section, we will discuss about some tasks, some detail in computer vision, frameworks and libraries required. Also, we will take a little bit of perspective about the deep learning, or the so-called AI perspective in autonomous vehicle, as well as some other computer technicalities. So the first thing is automatic versus autonomous. Well, it is we have been involving computers in all our electronics, all our products, but it is difficult to understand whether something is autonomous. So let me give you an example, or maybe later on we can draw an analogy of how we can go. So suppose I say that you have a car and you put a brake on your accelerator and then you start driving. So the question is, will that car be autonomous? So obviously the answer is no, because you can't turn your steering, you can't steer yourself, you can't brake. So even if we give you that capabilities that you can have automatic braking system, let's say you can have a steering system which will be controlled by some computer and computer codes, still that won't be completely fully autonomous. So it is a very gray area where we translate from automatic to autonomous. So so this gray area is defined by the amount of human intervention or the driving intervention in that. So SAE has defined 6 levels of automation, that depending upon the degree of human intervention possible, which is from level 0 to level 5. And some fun facts are like Tesla's autopilot, which is currently here, is still in level 2, and level 4 and level 5 are yet to come. And believe me, in all of it might come in 2030, but still we have far way to go. And a little bit of very interesting thing came up last 2 years. It was open in pilot by Comma AI. The person behind this is Geo Hortz, the man who was the first person to actually braille-jake Apple. So he developed a company and made all the code, all the technology open source. You can have it at your home and you can port it. You can check out. Next thing, okay, the electrical and the electronic team. So this team is actually the power behind the machine. Okay, so you have the logic, you know what to do, but everything will be run, would be controlled by the electronics and the computer equipments and the team. So the standard tasks are that you have to have a power supply to all the components. Obviously, you will have a battery. That battery can be a lead powered battery, or that can be lithium powered or lithium polymer battery. Then obviously you will have some circuits, because all the control things will be in the circuits. Then you need to connect the vehicle to the surrounding. You will have to use sensors, and you will have to interact with the surrounding. So in any robotic system can be simplified into 3 simple steps, or 3 simple components. You have sensors, you have control system, and you have end actuators. Now in sensors, these are simply input device. This can be perception for human, like let's say we have 5 sensory systems. So in the same way, any vehicle, any robot, any device can have a lot of sensors. It will be collecting data from the surrounding. Then the control system, also you can say that it is actually a control system and processing unit. So the processing unit will be collecting the data, analyzing the data, drawing some inference on those data, and then generating some commands. Now these commands will have to be executed by some hardware. Okay, again we started from the physical world, we took the data, we went into the digital world, and now again we are actually exerting our influence on the physical world. So these end actuators, also called actuators or effectuators, are maybe like a thruster, they may be simply engine, the exhaust, they may be simply, let's say you have a system for steering, so that steering mechanism is also a kind of end actuators. So the core part, which is the processing part, so it's simply, you can have a lot of terms on internet like microprocessors, microcontroller, or computer, but let's oversimplify it and say that it is simply a computer, and it is just all the hardware that you need to run the code, as well as read and process the input data and the surrounding data. So some of the most famous computer system, we can say, because these are actually combination of computers and microprocessor, microcontroller. So most famous is Raspberry Pi. You might have heard of it. It is actually simply a computer without a laptop, sorry, without a screen. Next is NVIDIA's Jetson Nano. It is actually Raspberry Pi with an added GPU capability. So you can run all of your deep learning models, because they need a lot of parallelization and a lot of computational power. Next is Arduino. It is also very famous. This one is in fact microcontroller, and it is simply used for various specific purposes. It is out of the scope of discussing what is the difference between microcontroller and microprocessor. But thing is, you just have to know that these are the processing units, and all of your codes will be running on it. New technology, especially in electronics, has been in the last decades, called FPGA, field programmable logic gated array. So there is a product, National Instruments MIRIO, which has an FPGA, a CPU, as well as a lot of input-output port capability. So most of the electronic stuffs which are associated, where you are trying to work with more electronic side, you can use National Instruments MIRIO. So these are some photos of the right one is Raspberry Pi, Arduino Uno, and Jetson. You can see there is a fan, there is a heat sink on the Jetson, and below that is actually a GPU. That just shows that you need a lot of computation power for deep learning. Next is the sensors. So sensors are they're simply measuring devices. You have a thermometer for measuring temperature. You have camera for measuring the light intensity and taking the videos. So these are also sensors, but the difference is that we are attaching a digital system, so they need to be converted from analog to digital. So in most of the sensors, we are actually in few sensors we might use some analog to digital converters as well. So these are few important sensors that are used in AUVs or ROVs. The first one is inertial measurement unit, which is the inertial measurement unit, or IMU. This is actually also available in your Android mobile phones. Most of the pedometer technology, where you calculate how much distance you have run, does not independently work on it, but it is used in all the motion characteristics. It has three components: magnetometer, gyroscope, as well as an accelerometer. You can see the diagram below. These are so in any AUV or IUV, you are pushed to have various degree of freedom of motion. So an inertial measurement unit helps in that. Second is a pressure transducer. So it's simply a pressure sensor. Now the thing is, you have to know where you are inside the water. Okay, you have to localize yourself. So that depth characteristics is given by the pressure transducer. So you measure the depth, you measure the pressure, and from that you calculate the height from the surface, the depth from the surface. Next is very important thing, the camera. So whenever you are driving in a car or riding a bike, let us assume that you want to get rid of, let us try to find the most crucial sensory system that is used. So if you get rid of that sensory system, you won't be able to drive. So it is almost 85 to 95% of the time you use your visual system. Okay, very rarely when you're driving bikes, maybe you can hear from your back and maybe do some extra analysis, but most of the time you need vision. So camera is the most important sensor in case of ROVs, in case of AUVs, and also this is used for navigation as well as for transmitting the data. So next, some other sensors, they can be classified in navigation and data collection. Navigation are those sensors which will be helping the AUV itself to maneuver, to move around. They can be depth sensor, I've already discussed, hydrophones, Doppler velocity log to calculate the velocity. collection sensors are actually associated with different type of projects that in your, like let's say you want to measure the pH, so you have pH sensors, you want to measure the fluorescence, and etc., etc. So next, this is actually a practical aspect, and this is the main thing you will have to practically do if you join a club. And this is sensor interfacing. You have a sensor, and you have a board that will process the data. So what you need to do is join those, attach the sensor with the board to read the input, and later on maybe process it. So it involves a series of electrical and electronics components that you might be using in between the board and the sensor to collect the data. So this is the practical thing that you need to know. This is just an example of how you use an IMU interfacing with the Raspberry Pi. Now the computer team, this is a glimpse of our computer members working in our club. So the question is like, what do we do in computers? Because there are robots and robotics. There have been a lot of improvement in robotics, but most of them have been in embedded C. So in the recent rise, what do we do and where do we stand? So we are simply bringing the intelligence to the intelligent system. Okay, so whatever advanced devices you have, they are dumb until unless we have a good logic, a good code running behind that. So this is just a standard division of the tasks that you need to do. Or the first is the perception part. Again, you can relate these to the electronics because electronics and computer parts go hand in hand. So the perception part is where you perceive about your surrounding. You collect data from your surrounding. Okay, so here you can have a lot of sensors. But this is from the computer side. So we won't be discussing about the hardware part. And then the path planning. Okay, obviously, once you know about the surrounding, once you know where you are, now you need to go from some point A to some point B. There might be some hurdles in between. So you might have to maneuver from, like, let's say this is a hurdle, then you might have to maneuver from right to left, or maybe decide where you have to go. So that is path planning. And then it's just control, that when you have decided the path, you need to give commands, and those commands will be controlled, need some extra control systems to be executed by the effectuators. So this is just a generic autonomous vehicle flow that you have the sensors. Now you can club all the computer and electronic system together. This is a sensor, you collect data, then you generate a perception and understanding. Then you develop a localization, that where you are, a sense of relative distance between different objects. Okay, so that is also called map building. Then you can develop cognition and planning. Then the motion control, okay, let's move ahead, straight, turn, light, left, and those commands will finally be given to the actuator for the actual movement. So the perception, as I've already told, like this is a car, there are a lot of sensors involved, a camera, radar, lidar, GPS, others, and all of these sensors are combined together to detect different things, lane detection, traffic detection, free space detection, as well as localizing where you are. So one part is where you are detecting what are other things in the scenery, and the second part is you are trying to locate where you are with respect to other things. So you want to have a relative idea of your whole surrounding. So once you have that, you have perceived the surrounding, the next goes is the planning, where you on the route you predict other, let's say there are other vehicles, a dog is moving, so you predict their movement and predict whether they will be in your path or not, and with that respect you change your behavior. Then you have a trajectory. Then you take the understanding of map, use some controllers. So this is a PID. This is the actual controller that you might be using a lot. And PID comes in electronics, actually. It is a proportional integral differential controller. So, and then next is MPC. This is actually an advanced PID controller also. And there are some other controllers as well. So just a basic overview. So I already told you path planning. So there's this car in front of you. You just have to maneuver from the left. And the next is obviously the control, that steering, braking, and pressing some, okay, showing the indicator, okay, we have to move, turn left, turn right. So this is the actual part that a human will see happening. Rest of the thing was actually happening behind the scene. This would be something which would be happening in front of you and you can observe. So a little bit detail into computer vision. This is the, as I have already told, vision system is the most important thing in autonomous vehicle as well as in underwater vehicle. So this is simply the science that deals with giving computer the ability to understand. Okay, you can see, the camera can see there are a lot of objects, but these are all pixels. Okay, you need to understand that all of the objects that are in front of you are different objects. You need to classify those objects, like this is a car, this is a man, this is a road. I have actually a better GIF next in the next slide, so it will get clearer. So the understanding and extracting information and drawing inference part comes in computer vision. And as you can read, researchers believe that theoretically cameras are the only sensor that any autonomous vehicle needs. So, but we are still far away, as you know, from Tesla and their products. So this is just an example of this system is called object detection, where you are detecting where an object is and what an object is. So it's two-part, localizing the pixels as well as classifying what is that. There is also an advanced part of our object detection called image segmentation. It is also even a more cooler part. The difference between this and this is that you just draw a bounding box between them, but here you know exactly which pixel belongs to which. So you have gone with more accuracy. You exactly know where is the footpath, because in this one you can't determine the footpath, right? So you need to know where is the footpath, and so you will travel. Okay, this might get confusing because I'm discussing about cars, because that are the most common thing that you observe. Underwater vehicles also behave like same. So you will be detecting debris, you will be detecting old ships, you will be detecting animals. So things would be almost similar. So the thing is, how does it happen? And we haven't discussed any technical aspects. So there are some libraries and some standard frameworks that can be developed. The OpenCV is actually the most fundamental and good to go library that is for computer vision. And you also have a lot of inbuilt image processing, line detection, contour detection, and a lot of all the processes available inside the open detection already built. So you just need to call a function. And they also have some neural network capability as well. Next is this photo is actually done by YOLO. So YOLO stands for you only look once. This is a very fast and efficient object detection. SSD is also something like YOLO with a different architecture. There is a newer architecture coming called Efficient Det. This is actually developed by Google. This is more efficient. It gives you a higher frame rate and it is more scalable. There is one also we need to mention. It is Detectron by Facebook. Now, this is very important. The current hype in artificial intelligence and where artificial intelligence goes in. So I have already discussed a lot of applications, but all those applications, I never told you like what is YOLO, okay? How does it do that? So this is actually, YOLO is simply a YOLO, SSD, Efficient Det, all of them are neural networks. So they come under deep learning. So, okay, actually I have mentioned artificial intelligence is nothing. So it's simply deep learning. So that is just for layman. So neural networks also have a lot of capabilities, like I've mentioned object detection and image segmentation. There is a very good technology which is used by Marines, especially advanced technology. This is called SLAM, simultaneous localization and mapping, which I was mentioning earlier. And this is something especially associated with underwater vehicles, SSL, or sound source localization or acoustic source localization. Because problem is underwater, you have visibility problem. Now that visibility problem might arise because light cannot go beyond 50 meters underwater. So you need some other physical, like other than RF or other than electromagnetic, some other physical properties so you can utilize. So sound acoustics is the best option currently we have. Also, you can use deep learning in case of sensor fusion. And this is actually, Tesla is currently utilizing 8 cameras and using sensor fusion along with a lot of neural networks to currently have their open pilot system. This computer team part is if you have a computer cell, there is very good option to have a machine learning cell in your club as well. You can have tutorials, the seniors can train you, you can have discourse group for discussion. A lot of newbies come and they need to get started. So if you don't have a club, you don't get started. The problem is that you know that in first year, okay, this is C++, this is Python. You actually never see something working. You have never created something. So there is no fun and joy when there's not that much fun and joy associated when you see simply that, okay, you compile and run the code and you see a number 76 or 77. So when you join a club and you can do a lot of machine learning, you see things actually getting created. And obviously there are a lot of competitions and the recognition associated with it. This is a photograph of a slam where they have actually located the surrounding, as well as they have mapped the whole surrounding and located themselves as well. This is underwater slam where they have marked the whole terrain. Now, this is some computer prerequisites that need to be covered. So Python is good to go language, like the most easiest you can have. It is almost English-like, so it is very easy to get started. You can simply learn it in maybe if you learn. So it is very like preferable to use Python, and because there is a lot of open source support. Next is ROS. I You need to take. I have already bolded it, so made it bold. ROS is very important tool when you are dealing with any kind of vehicles, or whenever you are going for autonomous underwater vehicle, any robot. It has all the toolkits that you will most of the time need. So they have developed most of the time, most of the things like SLAM has already been developed inside. They have a simulation integrated. They have, and the important thing is it has been built around robotics. So it is very suitable that it is a good to go language. So if in case you are going for deep learning and for ML cells that you have, you can start with TensorFlow and PyTorch. Both of them are good. And if you are going for microcontrollers, now though for Raspberry Pi you need Python, so it's okay. If you are going for Arduino for specific purposes, let's say for searching, you can use you already a lot of people know C++ or C, so it's nothing. And the most important technical ability like you can have whenever you're developing is Google search. Like this is the best skill and most important skill that you need. Just search everything. Okay, it's like Stack Overflow has everything. So just do Google search. Whenever you're stuck, do a Google search, you'll probably find something. So yeah, that's almost everything. There was a recent development, Apex OS. It is actually a fork of ROS itself. It has been developed specifically for autonomous driving, and it is open source. So people can simply fork that and develop their own system. So this is something very important, very good. And yeah, that's almost everything. Thanks.